we should be recording now. So anyway, tonight we're going to start the second of the three procedural coding structures. Anybody remember what the three of them are? There's three. They're used in all, it doesn't matter what language you use. There's three main coding structures.
First
So,
one's sequential.
yep, sequential is the first one. The one we're going to start studying tonight is
Decision.
decisions or selection, sometimes called. And then in about 2 weeks or so, we'll start, what's the last one?
Repetition.
Yep, repetition or iteration. It's sometimes called the nerd term for it. So, so this is a big one. This one, I mean, the sequential isn't a big. Excuse me, I'm trying to adjust. I have my laptop in my lap, literally on a board, and sometimes I get it. Um, so far, all we've been doing is line after line after line after line, sequential, right? Now we're going to be able to make choices, which adds a whole nother feature to the game. Okay. And in Java, it's there's three ways to basically do it. And depending on what we're trying to do, how fast we're trying to do it, and things like that all come into play. Okay. And this is across the board. This isn't, I'm just teaching you Java right now. I can tell you this. When I learned programming, I learned Basic A, which was back when it came with DOS, the operating system of the computers before Windows. And that's when I started and I learned the logic behind programming and that. And I've never had to go back and relearn it. Okay. Because every language I've learned since then uses the same logic. So once you are competent in the logic behind what we're doing, it's when you go to a new language, it's more of you have to learn the syntax. But for the most part, and again, there's some syntax stuff that comes into play. But for the most part, it'll be pretty familiar to you once you know one language. Okay. So, yeah. And so that's what we're going to kind of concentrate on a little bit, or more so, again, with learning the decision structure that's used in procedural programming. So, that being said, I'm going to go ahead and again, you just butt in, or not butt in, but speak up if you have questions or if I'm going too fast or you don't understand something. Okay. So I'm going to start sharing my screen with you guys and ladies. When I say guys, you guys understand, I mean women and gentlemen. Okay. So first things first. All right. Are you guys seeing that?
Yes.
All right. So the first thing we got to make sure of is that we understand how the precedences work. So at the top, you have the math, okay, the actual operations of mathematics, okay. So they're done first. After that, relational operators are done first or second. And that's all of your equals to, greater than, less than, not equal to, okay. So all those are done second. And then the third one is the logical operators, okay? And there's basically four of them in Java. Not, okay? And, which is represented, not is represented with a bang, or that's what nerds call it, exclamation point, okay? But like if you're a Linux guy or that, we call that a bang. And signs are ampersands, two of them, or is two pipes. The pipe key is the one that's the uppercase backslash, which is above your enter key on your keyboard, at least on a PC keyboard. I don't know about Apple. Is Apple the same? Anybody got a Mac? Where's your pipe at? Is it the same place? Nobody wants to answer. Nobody
It's
has a
underneath
Mac.
the delete
It's
key.
underneath the delete. Yeah, yeah, underneath or back. Oh, you guys don't have a backspace, I don't think. But underneath the delete, right hand side, upper corner there, I would think it's you have the same QWERTY, basically the same QWERTY keyboard, but usually it's right above there. So you get two of those. And then the XOR, which is really weird and we hardly ever use, is a caret, which is an uppercase 6. All right. And that's their precedence. We do nots first. We do ands second. We do ors third. And then XORs fourth if you ever have one of those. All right. So let's look at this. So if I have a logical operator of a not, like if gender not male, okay? Okay. So if that statement is false, then it becomes true. If it's not true, it becomes false. Pretty simplistic, right? And we will use nots, but my speech on not is don't use not. It makes everything more complicated. If you have to, I mean, there's sometimes you can't prevent it, but if you have to negate something, then a lot of times there's another way to write it. Like I just said, if not gender female, well, then gender has to be male. So why not make it if gender male, right? Okay, and gets a little more, and these are common in algebra and everything. So very similar. So I'm going to pick on somebody. How about Eli? You there?
Yeah.
Okay, listen up. So all you're going to answer me is true or false when I tell you something, okay? So
Okay.
you're taking a class at, you're taking Computer Science 115,
Yeah.
and you're taking it at ICC.
No.
You're not.
No. Well, I am. Yeah, but like not there.
No, but you're taking it from. How's that?
Okay. Yeah.
Okay. So you got a true and a true. So if you read it, it's you're enrolled in Computer Science 115 and you're at ICC. So that whole statement becomes
True.
true, right? So because I got a true, whoops, and a true here. So if I come here, it says it's true. If, same thing, Eli, you're in Computer Science 115
Yep.
and we're taking it at Black Hawk College.
No, it's false.
Yeah. So now if I read the whole statement logically in my head, it says I'm enrolled in Computer Science 15 and I'm at Black Hawk College.
Then it would just be false.
It'd be false, right? Just listen, because we're not. Same thing here. You're enrolled in English 110.
Mm-hmm.
No, you're not.
No, sorry. I mean, I meant to say yes, like to what you meant.
No, you say false.
Okay.
And you're taking it at ICC.
True.
Okay. But the whole thing becomes what?
False.
False, right? And likewise down here, if both of them are false, then it becomes false. So generically, or whatever you want to call it, I can say that if I know the first statement is false, it will always be false. The only way it can be true is if it's always true, everything. So Java has something called a short circuit. Okay. And what it does is it reads the first equation. And if that one isn't true, the second one is never even looked at. Because there's no case where if the first one isn't true, that the total sequence can be true, right? You guys understand what I'm saying?
Yep.
Yeah.
In other words, nothing I do later on, if the first one isn't true, can change it from being false. Okay. If the first one's true, then it will go on to assess the second one. If the second one is true, then it's true. If the second one is false, it's false. Okay. Then that brings us over here to or. Nathan, you there?
Yes.
All right, this is for you now. You're taking computer science 115.
Yes.
You're taking it at ICC.
Yes.
So if I say that you're enrolled in computer science 115 or you're at ICC, that turns out to be
True.
true, right? Second one, you're in computer science 115
Yep.
and you're taking it at Blackhawk.
No.
Okay, so now it reads, you're enrolled in computer science 115 or you're at Blackhawk College.
True.
It's true. Yeah. If you listen to it in your head, you should know that you are taking 115. Next one, you're enrolled in English 110,
Nope.
but you're at ICC.
Yes.
So this one here, enrolled in English 110, or you're at ICC.
True.
And so we read the last one is 110 and Blackhawk, which is both false. So now if you're enrolled in English 110 or you're at Blackhawk College, in that case,
False.
yeah. So we can generically say that the only time an or statement is false is when they're both false. Okay. So get a load of this. If the first one is true in an or statement, does it need to go on any further?
No.
No. It doesn't matter what the second one is. Okay. How about if the first one is false? Does it need to go on to the second one?
Yes.
Yes, it does. Because if that second one is true, the statement could still be true. All right. So we understand that, I hope. This last one, I'm going to give you an example. There's an error in it too. If you're taking notes or that, this true right here should be false. The true right here in the upper left hand out of the 4. There's an error there, and I don't want to go back. I made this video a long time ago, and I'm going to get rid of it after this semester. But okay, so here's the scenario. We're going to call this true and false here cakes. Okay, and we're going to call this true and false up here pie. So the columns are pies, and the rows are cakes. And when you go to Grandma's house, Grandma's a great baker, and Grandma loves to make cakes and pies for desserts for her grandchildren.
You're cutting out.
Am I cutting out for everybody?
Not for
No.
me.
No.
Okay. I'll try again. Okay. I'll start again. Whoever said I was cutting out. Okay. So these are my cakes. These are my pies. Columns are my pies, and these are my cakes in rows. So when I go to Grandma's house, she's a great baker, but she's also from the old country and lived through the Depression or whatever. Well, your grandparents wouldn't have, mine were. Grandma has this thing where, first of all, you have to eat dessert. You don't want to, Grandma would be sad if you didn't eat some of her dessert. But Grandma isn't of the opinion that you shouldn't be a pig either. Okay. So you can either have cake or pie, but you can't have both. Okay. So here, if we're going to eat a piece of cake for true, can I have a piece of pie for true?
No.
No. So that's why this one should be false. So if I have cake and pie, I can't do that at Grandma's house. The next one is if I have cake and I don't have pie, is that okay?
Yes.
Mhm.
Yeah. So that one's true. Down here, if I don't have cake, can I have pie?
Yes.
Yep. So that's true. And we said before that we don't want to hurt grandma's feeling. So we cannot not have cake and not have pie. So that one's false. So in this one, basically the scenario is you can't have two trues and two false or two falses. You have to have one, only one. Again, it's the name of this is exclusive or. So you can only have one true or one false show up. And I can't even think of a time I've used it. So just to let you know, but it's out there. Okay. So any questions over the logical operators? Those are the four.
No.
And we said, remember, not to use not unless you definitely need to. And there'll be instances you need to. All right. Let me see if I can get rid of this now. Oh, no, I don't want to share it. Let's see here. Go away. There we go. And let's switch over to here. All right. So this week is week 3. And if we look at this, I gave you some, that chart and that comes from this video here. There's like 3-4 videos I made here for you that you can watch at your own leisure. This one has flow charting and that showing you how decisions are made. Okay. And it lists here sequential decisions and repetition. Down here in the assignment that's due next Tuesday, we're going to read chapter 3. We're going to spend at least 2 lessons, 2 weeks on this. 3 programs to write. We're going to write one tonight. Here again is the logical operators. Okay. The other thing you should always be aware of, these are Boolean operators. What does Boolean mean?
True or false?
Yeah. The only answers we can get from them are true and false. All right. And I need to fix this link. It doesn't work right now, I don't think. No, they took that video down. I need to fix that. Down here, I talk about how to create a random number, one of the ways to do it. And I'm going to show you how to do that in a few minutes using this method, which I prefer over the other method. Okay. I think that's good on that. So there are 3 lessons, or 3 assignments, but we're going to do at least one of them tonight. This second one here, I'm going to do the random month with you, I think. It's pretty easy. And then you got to do rock, paper, scissors, which is also called what? Anybody know? It's also called Rochambeau. Okay. And a couple little things on it. So you're going to play. So it's rock, paper, scissors. You're going to play against the computer. Okay. And so the computer is going to pick theirs by a random number, but you're going to convert it into rock, paper, scissors. The game is not 1 2 0 1 2. You have to whatever you pick versus what the what you call it, the player picks, the computer picks, makes a big difference. You want it to say, you want it to be user friendly. Let's put it that way. Maybe we should do that one. I'll think about it. Maybe we'll vote. All right. So let's Let's go ahead and write a program, an example program first. So again, 3 programs. All right. All right, let's go up here and we're going to start a new project. Of course, it's always an ant. And I'm going to call this, let's call it Tavern Helper. Or how about Tavern Bouncer? That's a good one. And we're going to come up here and project will be the Acme Tavern Bouncer. And this is Tavern Bouncer.java. And date is 2/2/2021. Author is yourself. And the purpose of this program, a program to decide what a user can drink based on input of their age. And since there's going to be input, I'll need what? What do I need for input?
Scanner.
Yep.
Yeah.
I have to wait a minute here. Why didn't my library pop up that time? I wonder. That's strange. This computer is very fast, except when it goes to usually loading that library. It usually sits for a while. I'm going to indent a little bit here more. That's pretty good. I'm going to come down here. Just put a small divider in so we get used to doing it. This is more for when our programs get real long. So there I have my basic outline. I'm going to go ahead and save that. And then I'm going to instantiate my scanner. So I'll say scanner, and I'm going to call it, my scan. How's that? Is equal to a new scanner. And you should be getting used to this by now. Some of this stuff you should have it so you don't have to look it up all the time. Okay, so now we have our scanner instantiated. Okay, so then I need my inputs, or I'm going to just call them input. So first thing I want, print screen, print line, and I'm going to put in a little header so we know what it is. something like that. And then a system dot out dot print enter your age. And then we can go ahead. Again, our scanner's named my scan. So what data type is age going to be?
Integer?
Yep. So we got an int age. Meaningful name, right? My scan will be the next int. Okay. So then I can do processing. Because I've got what I need here as my input. I only need the one, as far as I know right now. So the first way I'm going to show you how to do this, I'm going to show you multiple ways, okay? So the first one is going to be the old way. It's called inline if. So I'm going to just say if age is less than or equal to 12, okay? We're going to say, I forget if it's a, oh, we'll just practice putting them in braces. So we'll say that one's going to be system dot print. This is faster this way anyway. Print line. You can drink milk. So then we come down here and say if age is greater than or equal to 13 and age is less than or equal to 20. Notice there's no semicolons after your ifs, your comparisons, okay? If you put a semicolon in there, you're going to have problems. Then, oops. I'm scrolling down again.
How come you had to put new brackets in each time?
Because then it only pertains to this. Because if I had more than one statement in here, you can actually don't put these in, it'll work fine. But you want to get used to putting them in. Because a lot of times we're going
Okay.
to do more than one thing. And it's a grouping process. Let's put it that way. Okay. Kind of. It's just a good
Yes, thank you.
practice.
Yeah, no, thank you for explaining.
Oops, that ain't right. Equal to 41. And then finally, the last one. And it's just if age is greater than equal to 64. All right. So this is how we would have done it with just inline ifs. I actually know people that still write code this way. But so if I click on it now, comes up, asks me my age. If I say I'm 12 years old, I drink milk. If I'm 40, I drink beer. 15, soda. 60, wine. And 70, cognac. So it seems to work. Okay. Few things to look at. I have to put in the high limits. Oops. I have to put in both the low and the high limits if I do this. And I'll show you that in a minute. So this is the old way to do it. Okay. So now what we do is more like this. Okay. So if this, then we can do and I can get rid of the lower limit. And then I can come down here and get rid of this. And then I can come down here and get rid of this. In the first one, you have to realize that it ran every one of those. Even when I put 12 in, it compared the one for the 20, the 40, the 63. Every one of them was compared. Okay, so it took that much time. And then this one changes to just a plain old else. All right, so I got those cleared out. Okay, so now if I put in 12, it says milk. If I put in 43, I get wine. So you can see here that it works just as well this way. And this is faster because once it finds like the 12 here, none of these down here ever run. Where in the last one I showed you, every every if executes. In this one, only the one. Once it's found, let's say I'm 40, none of these execute down here. Okay. So this is definitely faster. Now, again, when I talk speed, we're talking, milliseconds, go away. Just minimum uh, amount of time nowadays. So don't do this. What I'm going to show you, this one you can do, but let me do this real quick. Just to show you something. All right. So
Mayor,
if
quick
I,
question in chat.
oh, I don't, hang on. I didn't have my chat on even. Where is it even at? Why, I don't even see my chat. Oh, there. Hopefully those were, my mic is acting up. Is this one of the assignments for? No, it's not. This is just an example of different ways to do a problem. Okay. And the preferred method, okay, is the LSIF. Because watch what happens here. Let's say that you did this like we did the LSIF. So now I'm going to get rid of this and just use the high numbers and not put in the low. I think that's right. That's right. That's right. That's right. Okay. So now if I run it, and I'm 12 years old, what do you think I'm going to drink?
Milk.
Okay. I'm not going to be thirsty by the end of the day. I'm going to drink milk, soda, beer, and wine. The only one I won't drink is cognac. Because look, if I put in 12, is 12 less than or equal to 12? Yes, it is. Is 12 less than or equal to 20? Yes, it is. Is it less than or equal to 40? Yes, it is. Is 12 less than 63? Yes, it is. The only one it isn't is over 64. So when you do inline ifs, you have to put in that lower equation in the and, or you'll get a drunk kid. How's that sound? Okay. So that's just, again, different ways to write the same program. Now, like I said, most of us nowadays um, use the else ifs. Okay. Let me look at something real quick. Okay, we're good. All right. So now let's get rid of this one. We can just keep that for your own uh, thought process. Make sure you understand it. Okay. And let's take a look at another one. And this one is one of the ones in the assignments. So I'm going to call it month. I wonder if I have generator. No. How about just month picker? Better than nose picker. Oh boy. Okay, so now I got something called month picker. And so this is going to be project Acme month picker. And this is monthpicker.java. And the date 2/2/2021. Author. D. Peterson. It's pretty amazing the amount of snow I have at my house. Even I live down on the by the south side, down by Bartonville and West Peoria, and that is we can see our grass here. And then I drove up to I go to Northwoods Church, and the grass up or snow up there was deeper than it is here. And then where my kids live up by Chicago, they got over a foot. So it's kind of we're kind of on the dividing line here, I guess.
I was also in Chicago this weekend. It was super snowy up there.
Yeah. Oh, I have great grandkids that are like 2 years old, and they love it. I mean, they just think it's the greatest thing. If I never saw snow again, I'd be a happy person.
I live in Chicago. The parking's horrible right now.
Yeah. Program to randomly choose a month. Um, okay, that's pretty much what it does. Okay, get that, get rid of this, indent this, move this down a notch. There we go. Put this over here, don't need that. Put in a divider here. All right. So again, there's my setup. I save it. On this one, I don't need any user input. Okay. So I'm not going to get a scanner, but I am going to get a different utility. I'm going to import a Java utility called random. Okay. Now there's another random built into the math um, library that's already in your, I think, let's see what it is. Oops, hang on. I think it's RDM or something like that. Let's see if there's, so if it's right here. Yeah. Oh no, it's random. So you can use that one too if you want. I don't use it. I'll show you what I do. I generate an object or instantiate an object just like we do the scanner. So I'm going to say random, and I'm just going to call it RDM is equal to a new random. And there's so now I have an object that has methods that I can use. So this instantiates a object to generate random numbers. Okay. So now I'm going to generate a random number. It's going to be an integer, and I'm just going to call it month num, like that, is equal to, and I called it RDM, and it'll be next int. And how many numbers do I need?
12? I
Yep.
don't know.
So I'm going to say 12. Okay. The problem with that is somebody that hasn't answered, uh, what month were you born in?
March.
Okay. So he's born in March. So that's what month?
Third.
Oh, no more. I'm going to make it month 2. Does that make any sense?
Yes, because
No.
of zero.
Well, yeah. Okay. So you know the trick. So if I generate 12 numbers, they're going to start at 0 always. So I'm going to get 0 through 11. So that would make March month 2. Well, that doesn't make any sense. It's not programmer friendly. So what we're going to do here is we're just going to go ahead and plus 1 here. So now instead of 0 to 11, whatever you put in here, it will never generate that number. It's always one less than that. Okay. So here, and nobody wants to have that. How about days of the week? If you were going to do days of the week, you'd put 7 in there, but then wouldn't you want to add 1 to it? I would think so.
Yes.
Yeah, it just makes it easier for everybody. I mean, could I set my decision up with January being 0 and December being 11? Sure, I could do that. But why? It's more likely that you're going to make a mistake if you were to do something like that. Okay. So I'm just going to put this in real quick. So that's my input up there. Okay. I'll just put it in. That's really not my input there. This is my input here. It's the only input I need. So now I'm going to process that. All right. All right. So now it's going to generate a number and I need to turn it into a name of a month. Okay. So I could use a series of if else statements, right? Just like we just did for drinking. Basically, the same thing we did for the drinking, I could do here by saying if month num is equal to 1, then that's equal to January. Else, if month num is 2, it's equal to February, et cetera, et cetera, et cetera, right? Well, there's another structure called a case structure, okay? And some programs have case structures, some don't, or languages. This one happens to. It's not always the best one I've ever seen, but it works for this purpose. So it's called a switch. And we're going to switch. What do we want to switch on? We want to switch on month num. And then we're going to put our brace in, and it would look like that. And we start out with case 1, and then a colon. Enter, another brace, and then we can put in here, you know what we're going to do? Let's go up here and declare a variable. Let's call it string month. And so here now, it's as simple as just typing in month is equal to January. I'm going to put in space. You'll see why. January. And then we have to put in a keyword called break. Because if we don't, it'll keep going down and reading all the ones below this. So then let's say if I put in a 1, it would print out January, February, March, April, May, June. And that isn't what we want. Then we'll go on here to go on to case 2. Very similar. And then we just month will equal to February. And make sure you spell February correctly. And once again, we need our break in here. And then what I'm going to do is do this and Control C it, copy it. Then I'm going to come down here and paste that in like that. And then I'm just going to change that to a 3 and that to a 4 and this to January, February, March and April. then I'm going to go ahead and copy this. Control C. Come down here. Go over this. Oops. Over this side here. And Control V to paste it in. Hit enter. Go back over to the side. Control V to paste it in. I just go back up. This will be 5, 6, 7, 8, 9, 10, 11. Did I miss one? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I did. 9, 10. 11 and 12. I can come up back up here. Make sure I get my spaces in there. Sure, you spell them right, especially February people sometimes goof up on. And so get all those done. I'll give you a second here. Make sure this is lined up with that. So now I'm outside the switch and I just type and I put a space in already there, so I don't need one there. Okay. So what's wrong with that? Okay, let's look. Why is that not?
Isn't string, you can't do string with math, right? So a plus, is that correct or am I wrong? I'm sorry.
This should be month is not, it's a string. Oh, it's not been initialized. Okay. So this will be, we need to just do this. Just put double quotes there is equal to nothing. And that goes away then. So I think it looks pretty good now. So if I run it, so the month that was chosen for me is May. And we want to make sure we get a January and a December. So I'm just going to keep hitting it until I do. There's December. That way I know it's generating them all. There's January. So I'm pretty confident now that I'm getting all the months. And I'll put in blank line. And then I'm just going to put, and this is just goofy what I'm doing here, but it allows the user, again, later on, when we can run the program multiple times, we just want to let the user know that they're done using the program. And likewise, again, it's not a big deal, but we'll go ahead down here and just tell the programmer that might be looking at our program that no code follows. So again, this is called a switch. Okay. Use the switch. And if you've ever programmed some other language like Visual Basic, you can make ranges in here, like case is equal to one. In other words, we could have done the tavern one, the drinking one, but this one doesn't work well with that because you have to use case one, case two, case three, case. So I'd have 12 cases for the first for milk. Okay. And they could fall through. Okay. Watch this. Don't do this to your program, but watch. If I don't put these breaks in, all right. Okay, December, right? December, right? December, right? December, right? December, right? So we don't even know what number is being generated, but what it does is it says, okay, if I rolled a one, it'd say the month is January, but then it would go right down here, make it February, make it March, et cetera, et cetera, et cetera, till we get down to December. So I'll never get anything other than December. And if I would have put the print statement up in here, it would have started like, let's say I rolled, if I put in a six, then it would have said your month is July, August, September, November, et cetera, et cetera. It'd print all of them like we did with the tavern age. But if you get your breaks in there, you should be able to run this and generate a month. I thought I put a header in here. What happened to that? Maybe I didn't. Oh, we got to have a header. That's cool. Oh, much better. Oh, God. So anybody got one that isn't running that we need to look at?
Can you show the very bottom again?
Sure. Okay, while we're waiting here, giving people time to catch up, I want you, everybody that's here right now, to quickly go to Notepad or Word, and in your portfolio, you type or you do a little note to me that says you were in class on 2-2 at 5:05. I was in class on 2-2 at 5:05, and put that in your portfolio. And I'll give you a minute or so to do that. I was in class on 2-2 at 5:05. And then that'll get time stamped so I can tell who stayed in class and who didn't. Not that I'm,
We're putting this on our submission.
yeah, in your portfolio, just put 2-2 attendance as the title. Okay. So just type something in either Notepad or Word, save it, and then put it in your portfolio real quick.
Can we use Drive?
Drive, I don't even know what that is.
Google Drive.
Um, I have no idea. Imagine if I can read it.
You can just right click on the desktop and click Create Text Document.
There you
It
go.
works on both Mac and Windows.
See that? What you learn here?
Can you repeat that one more time?
Just right click on your desktop and create text document. Like this, I imagine. It's this new text document. Then just whatever. Or you could, just then save it. All right. That way, if the college ever asks me, well, how do you know if somebody came? Well, I don't take attendance normally, but every once in a while. Again, make sure when you're doing your programs, you don't take any shortcuts. These programs aren't that long that you need to be taking any shortcuts. In other words, make sure you always have sufficient internal documentation. Okay. Make sure you're naming your variables with meaningful names for the program. Watch your indentation. Again, if you look here, that brace lines up with this brace. This brace lines up with this brace. And then this brace lines up with, oops, that brace. So it's very neat. Okay. And you can tell readily that these three lines here are outside of the switch, which is all this stuff in here. I'll show you a little another thing that some people do. In other words, if I was to do this and then declare my variable, I don't even know that it'll let me do it on this one. So if I take that from here and put it in here, let's see if it'll let me do that. No, it won't let me do it anyway. Okay. I'll show you another time on a different example that it'll work on.
My program isn't working.
It isn't.
Yeah.
You want to share with us?
Yeah.
Okay, hang on a
Well, I'll
second.
be stupid.
No, you're not. Hey, we're learning how to do this. It's not a. Okay, you should be able to share with us now.
Okay. Desktop one.
Should be a green button or something, I think. Yeah.
You can see now.
Yep. Can you make yours? Yeah, bigger. Okay.
Yeah. Okay.
All right. So let's see. We got random there. New. You're missing a space. Is what's wrong. Nope, not
And
there.
then
Take that space out. Now, right after new, you're missing a space.
okay. And the second line.
This one here, next int, it's int, not an L.
Okay.
Nope, capital I. Okay, so now that's fixed. Okay, and let's scroll down. That 3 is, what's wrong with that? Keep scrolling down. Scroll back up. Let's fix the 3 first. I can figure out why it's doing that. Oh, you got a colon, no, or is that a semicolon?
It's a colon.
Isn't it? Okay. Put your mouse over it so we can see what.
Oh wait. Is that in?
Oh, the one above, you don't have an opening brace after 2. Yep, enter. Put an opening brace. There you go.
Okay.
Oh, that one's gone. Okay, so go down now. Oh, look at that. Whoops, we still got something going on here. Put a space. Oh, go back up to the top. And right after month, put space, equal sign, space, and 2 sets of double quotes. It's just saying that you didn't initialize it. Okay, so now
And
try.
again.
That's good. Try it again. Run it.
Okay, where are you?
Up at the top there. No.
Screen sharing thing.
Green arrow. Green arrow. Green arrow. Top row. Green arrow.
It's blocked by the screen sharing thing.
Oh, just move it out of your way.
Where is
We can see it.
Oh, there it goes. Sorry.
Scroll up so we can see. Okay, why is it? There you go.
Okay.
And
Thank
then
you.
we added a header. I'm going to show it to you here in a minute. So go ahead and stop sharing. Okay.
And did you want us to put comments in for the output too?
Oh, didn't I? Probably not. Hang on. Okay, you guys should be seeing this now. And yep, we can come down here, enter, and just say output. Maybe even put a space here, line feed. There we go. That looks nice. And then the young lady we were just talking to, we added this line right here underneath month.
Got that.
Anybody else got problems?
I don't have a problem necessarily. I do have a question.
Okay.
So I was just wondering why we use integer opposed to instead of byte and short.
You could.
Okay.
It would be more efficient. Okay.
Okay.
So if you did that, I would not mark it wrong. I'll tell you about byte. I don't mind short. Okay. The problem I have with byte is I normally only use byte. Okay. If it has something to do with the computer. In other words, if I wanted to change the color of something, most colors are 255, 255, 255, or whatever would be black. Or no, that'd be white, and 000 would be black. So if I was doing something like that, I might use byte, but I usually don't. When I program in basic, Visual Basic or that, I do tend to use short just because when I learned how to use short in that, I did it. But I'm doing you guys a little bit of a favor um, by just allowing you to use integer for the most part and double for the most part. Okay.
Yeah, I guess I was asking because in my cost of driving that I built, I
Yeah.
was trying to get rid of like the number of like decimals after. I just wanted it to be like like $20.69, but I had
Yeah.
$20.698 or something. I didn't know how to make
Okay.
it.
Here, I'm going to show you. Okay. Let me do this. Don't add this. I mean, I'm adding this to my program, but if you copy this, don't leave this in your program. Okay. Rem it out or get rid of it. So let's just say that I put in something called double number is equal to 29.3456. Okay. And then I want to print that out. And I'm going to say system.out print F. Okay. And we're going to allow this to work for us now. Later on, I'll show you another way to round that to make it. Because if we just cut stuff off all the time, that can lead to problems, especially like if we're doing banking and taxes. But I'm going to just do, oh, come on. So now I'm going to say this. The number was, and then I'm just going to put in 0.2, oops, I'm sorry, percent sign 0.2 F. Okay. Then I'm going to go out here and I'm going to put comma number. Okay. So it's printf for print format. And this means I want a Oops, I forgot my, let's see, yeah, 2F. So it's a 2 decimal float. And let's see if that works. And there you go, 29.25. If I make it a 3, of course, let's see what I get. Does it round it or does it just cut it off? It rounds it up to 6 from 5, okay? Let's go the other way. What if I do, what do we got here? Okay, so if I put a 1 in there, let's see if it leaves it as a 2. And it does. Problem, I think, comes in, if there is one. Let's make this a 5 now. Leave this at 1, and let's see if it rounds up. Okay, it does. It went to 3, right? Let's say this is a 3. And let's see if it goes to 4. And it does. Okay, so that's not a problem. So this is how to format a floating point. So it only shows 2 decimals. Usually that's the one we're looking for, right? If we're talking about money, this is the way we should output it.
Is it okay if we didn't do that for our cost of driving activity?
Oh yeah, I just introduced it right now. So yeah, don't worry about it.
Is it okay if we did that a different way?
How did you do it?
It was, I think, what the book said. Can I just share my screen to show the code?
Yeah, hang on. Because there's more than one way to program stuff. I just happen to be the guy that's going to grade your papers.
Can you see that now?
Yeah, I can.
It's right here.
All right, let's see what you got. Oh yeah. And again, that's an algorithm to round to 2 numbers.
Okay.
Okay. So what they do is they look at what they do. Now I have to explain this. So they take your cost of driving, and so let's say the cost of driving is $20 and 0.391. Okay. So they take that and they make it $2,000, $2,039.1 right here, right? You with me? Hello, somebody say, yeah, I understand.
Yes.
At least one person is.
Yeah.
Okay. So I'm going to take that number, multiply it by 100, which is going to give me a number in the thousands. Then this takes place. It changes that into an integer. Okay. So now I've just got 20,000. What did I say? 39. The 1 is cut off, right? Then it says, okay, and then divide that by 100. So now I've got 2931 or 20, whatever it was. So I only have 2 decimal places and we're good to go. So you can definitely use this. Make sure to write it down right now, because this is what I was going to show you later. Okay. And the good thing about this is you're doing it mathematically. You're not just cutting them off like you are when you're just formatting the printing. Because if you take that number, okay, if you take that number, go ahead and stop sharing, Nathan. Let me go back. If I take that, okay, So I print it out as a 2-digit number, right? And then let's see here. What did I do? I did something goofy. Did it print out right? Oh, I know what's wrong. Hang on. Right here, when you do this, if you use this one, you also need a /n for a new line. There we go.
Are we supposed to write that for our program?
No, I'm just showing you. These are just examples. So see what it's doing here? When I print it out, I can truncate it and cut off everything after the 2 digits. All right. But that doesn't change the value of this. So if I use this number later on, like I do right here, okay, and I'm expecting to get 2 digits here, okay, I'm not going to, because it's still, this number hasn't changed at all. If we come over here, or like we had it over there, and you do the mathematical thing, in other words, if I was to come here and instead right here go number is now equal to int, and then what was it, times 100, and then divided by 100. Let's see what that comes out as. And then we can get rid of this. I think, let's see. All right, let's see if that comes out right. And there you go. Well, that's down to 1 digit. I don't know why that came out right.
I think that the second 100 needs to be a float, like a 0.0.
Oh, yeah. Okay. You're right. There we go. So you can see we did it mathematically here so that my second number comes out correctly. Okay. So just something to think about in the back of your mind. Am I going to reuse that number in a later calculation? Do I want it to be truncated down to 2? Or do I need the full number? I think I might have mentioned before that that can add up to a bunch of money. When money is goes from bank to bank or investment company to invest, they might be moving billions of dollars at one time. Time goes, no matter how short it really is in the electronic world, there's a period of time that goes on while that money is moving. Okay. So there's some interest being generated, and it might just be pennies. Okay. On $1 billion, maybe, that is generated while that money moves from bank to bank. Well, how many transactions a day do you think? Where do all those pennies go? What if you could siphon off all those pennies? I would tell you that you would be a very rich person. Okay. So if we're losing pennies or tenths of pennies or hundreds of pennies out there, they have to go somewhere. Okay. So you want to be careful. Um, you know, when you're dealing with money, the mathematics of the money. Let's just put it that way. You don't want to just drop off tenths of cents and things like that and think like, well, it doesn't matter, because sometimes it does. And that really happens like when we deal with taxes, when they tell you the tax on something is 6.5%. Well, you know, that's 0.065 or 1/100th of a penny. The five is 5/100ths of 1 penny. Okay. So believe me, the government wants that whatever, 5/100ths of the penny. You don't get to not pay that. All right. Any other questions? So that program right there, I'm going to stop sharing and I'm sorry. Let's see here. I already stopped sharing, right? I'm going to stop recording at this point.